Yes, hi guys. So we are doing Kramers rule here. Question number 10. I was doing what is a Kramers rule. This is double M, not double M, but single M. What is Kramers rule here? Okay. Kramers rule. Okay, following to solve for solving simultaneous linear equations. Simultaneous linear equations are solved with the help of Kramers rule. What is a Kramers rule? I have already described here. Okay, so now let me again summarize this. What is this? It is applied to solve simultaneous linear equations. One thing, how do we find out? We find out these three equations were given. a1x plus b1y plus c1z equal to d1 we have taken. Okay, then a2x plus b2y plus c2z equal to d2. Second equation is the first equation I took here. Then third one I have taken a3x plus b3y plus c3z equal to d3. Suppose this is third equation. So these three equations where x, y and z are the variables. Now to solve the values of variables is known as solution of the linear equations. To solve the linear simultaneous linear equations, we have to apply the Kramers rule, which is usually done. I mean, usually we can solve the value of these variables. For that, Kramers rule is applied. What is Kramers rule? Now let me describe it. Now first of all, we find out determinant of the values. Determinant of d here I have taken the determinant of the coefficients of the variables. This is a1, b1, c1, a2, b2, c2, a3, b3, c3. So first we find out the determinant value. Okay, then to find the value of x, for example, okay, if I have to find out the value of x, then in that situation I have to multiply this x, okay, to the determinant d or d here. So xd equal to x into this determinant, because d value is this a1, sorry, this d1 d2 I have taken. Now let me again describe this so that it will be clear. Okay, so solve the simultaneous linear equations. What to do? Let me further solve it or further explain this. After explaining, then I'll solve the question number 11. Kramers rule. It is applied to solve the linear simultaneous linear equations. Simultaneous linear equations. Let's see it. Simultaneous linear equations. If we have to solve, then Kramers rule is applied. Okay, so what is the Kramers rule? Let me solve it. Now I have described that how to solve a determinant of order 3, a matrix of order 3. How to find the determinant of that, of order 2, order 3, order 1, order 4 and more. All determinants values are described. I have explained here. Now let me take what is the Kramers rule. Kramers rule I already briefly described. Now let me again tell you. It is applied to solve simultaneous linear equations. Simultaneous linear equations. As I took previously, let me take a linear equation a1x plus b1y plus c1z equal to, let me take d1. Okay. This is equation number 1 I described. Then I took a2x plus b2y plus c2z equal to d2. This is equation number 2. This is the first equation. Okay, this is solution we are finding out of the question number 10. So 10 is Kramers rule here. How to solve simultaneous linear equations. That the process here which I am describing. Okay, now let me take the third equation, a3x plus b3y plus c3z equal to d3. This is the third equation here. Okay, and take this is the third equation. Now how to solve these three equations? In this case, x, y and z are the variables. To solve the values of variables, to solve the equations means to find the values of these linear equations, these variables, unknown variables, where a1, b1, c1, d1, etc. are the constant values, are the coefficients here. a1, b1, c1 are the coefficients of x, y, z. Similarly, in other equations, and d1, d2, d3 are or scalar quantity or any numerical value. Okay, so these are numerical values here, scalar quantities. Now, these equations are to be solved. With that, Kramers rule is applied. What is Kramers rule? Now, by Kramers rule, the process is as follows. The process of it is as follows. What is that process? First of all, suppose x I have to find out. X is equal to d1. Let me take this is upon d, or we can take this is or this is, we write here delta 1 upon delta. Okay, some writers have written like this. Okay, so I write only d1 upon d. This is determinant value, and d1 is, what is d1, what is d2. Let me take y is equal to d2 upon d, and z equal to d3 upon d. Now, so know what is the value of d1, d, d2, d, and d3, d. All these values, first of all, we have to understand, and then solution will be easier. What is the value of d here, or delta here? D, which is determinant value. Here d equal to determinant of coefficients, the coefficients of the variables, is the coefficient of the variables. That means here d is written like this. The coefficients of these variables of the three equations are a1, b1, c1. This is a2, b2, c2. This is a3, b3, c3. So in d, we take all the coefficients of the variables. X coefficient a1, b1, c1. This is the coefficient of y of z. In the first row, we take a1, b1, c1, coefficient of x, y, z. Second row also, similarly of the second equation, a2, b2, c2, we take the variables, these coefficients of the variables. And then in the third equation also, from the third equation, a3, b3, c3, we have taken the coefficients of these variables. Okay, so this is the value of d. We will solve these numerical values. I mean, this will be a one quantity here. Okay, then what is the d1 here? Let me find d1. Now, in place of d1, what we do, if I take d1, then this d1 is equal to your d1. How this d1 has come, I'll just talk about that. But before that, in place of a1, a2, a3, we write here, this is d1, d2, d3. What the value of these equations, the right hand side, those values are replaced. If we have to find out value of x, then d1 is, in place of a1, a2, a3, we write d1, d2, d3. And these two are, as it is, these are b1, b2, b3, c1, c2, and c3. These are this is the value of d1. How this d1, d2, d3 has come? Okay, if I just multiply this by x, let me write here x into this d. d1 is equal to this d1. Let me write here. If I multiply x by d, this x by d here. Okay, let me write here x by d. So this is x into d. This x, if I multiply this x to this equation, this will give us a x1 plus b by 1 plus c. All those coefficients will come here. So in place of this first equation, here I have to write here a1x plus b1y plus c1 z here. In this, I mean d1, d2, d3 are the value of this equation. This whole equation will come here. Okay, so this, in place of this, we will write here a1x plus b1y plus c1 z. Okay, this whole equation will give us. Fraction to d will give us this value. Okay, so now let me write here. So d is nothing but coefficients only, the determinant of the coefficients of variables, where d1 is just we have to replace a1, a2, a3 by d1, d2, d3. So this is value of d1. If you have to find out the value of y, coefficient of y are b1, b2, b3. So this column is replaced by d1, d2, d3. d1, d2, d3, the value of these equations are to be replaced when we find the value of y. Then in place of d1, d2, d3, you have to just replace d1, d2, d3. If you have to find out the value of z, then c1, c2, c3 is replaced by d1, d2, d3. The values of these equations d1, d2, d3. Okay, so that will be then d2. So d1 is this d1, d2, d3, and d1, d2, d3. These two columns are same as in d, but only the first column is replaced by the value of the equations d1, d2, d3. But here, in place of this, if I multiply this by x, y, z to all these equations, so we will get here, if I add them with this x, y, z, if I add this whole equation, then this will give us a1x plus b1y plus c1z, okay, a2x plus b2y plus c2z here in this place. So by multiplying, okay, each column, this by x, this by y, this by z, and then adding them, first column is added to this and this, and then these are replaced by same. First multiply by x to the first column, second by y, and third by z, then add them in the first row. That will be then replaced by d1, d2, d3. Okay, so these two will remain same. This is how d1 is obtained. What is d2? And the d2 value is, let me write here, and d2, as I have told you, that this is for value of y. So second coefficients of y, b1, b2, b3 will be replaced by, and a1, a2, a3 coefficient of x are same as it. b1, b2, b3 only are replaced by d1, d2, d3. This is c1, c2, and c3 as it is. This is the value of d2. Now d3, because d3 is required for solving the value of z. So coefficient of z, c1, c2, c3, they will be replaced by d1, d2, d3, and a1, a2, a3 will remain same. b1, b2, b3 will remain same. Okay. Here I am taking only one equation, but this Kksharma's rule I'll take separately in one of the lectures. Okay, ahead, maybe the third one or fourth one. That lecture I'll take based on Kksharma's rule. Okay, so that is there I'll discuss about in detail and how this, what is Kksharma's rule, what's Kksharma and everything. But here I'm just introducing. Okay, sorry. So how to solve the values of x, y, z. Therefore now x is this is d1. This d1 is this value. So d1 upon d, y is d2 upon d, and z is d3 upon d. Now d1, d2, d3 are these values. This whole value, determinant value divided by d. D is this coefficient. Okay, so this upon this is the value of x, and d2 means this upon this d is value of y, and the d3 upon d is value of z. In this way, all the values are calculated. This is Kksharma's rule, we say. So Kksharma's rule is just to solve simultaneous linear equations, find the value of the variables. For that, this determinant way of determinant is applied. With that, makes the solving equations easier. This is how determinant is applied to solve the equation. Now let me take question number 11, which is one of the questions based on Kksharma's rule that will clarify the value of this. So let me take question number 12 here. Now what is question number 12? Let me talk about. The question 12, sorry, 11 question. Question number 11, because it was 10th one we have done. Now this is 11th question. Solve the following equations using Kksharma's rule. What is the equation which you take? Now, okay, solve the following equations. The following equations by Kksharma's rule. By applying Kksharma's rule. Let me take the equations here. This is 3x minus 2y, yeah, plus 4z equal to 5. This is first equation. Second is x plus y plus 3z equal to 2. This is second equation. Third one is minus x is equal to y minus z is equal to 1. This is your third equation. Okay. Now we have to solve it with the help of minus x plus 2y minus z equal to 1 and x plus y plus 3z equal to 2, second equation. 3x minus 2y plus 4z equal to 5. Alright. So these are three simultaneous linear equations. We have to solve them with the help of Kksharma's rule. Now let me apply. First of all, what we do? We find out the determinant of the coefficient of the variables of the coefficients of the values which we represent by t. So d is equal to represented, let me write here, represented by d, capital D. What is capital D? This determinant d is the coefficients of x, y, z. This is 3, minus 2, 4, 1, 1, 3, minus 1, 2, and minus 1. This is just coefficients of x, y, z. We take all the three variables coefficients we take here. Now we have to find out what is the determinant value of this. We know that what determinant cofactor of 3 into cofactor of 3 is 1, 3, 2, minus 1. Then minus sign we keep in between because this is odd number. This second element is lying in the first row, second column. So 1 plus 2 is 3. So minus 1 raised power 3 is negative. But negative sign is already there, which is positive here now. And 2, this value is also to be multiplied. 2 into the cofactor of this cofactor minus sign that I am writing here. Now this is minor. What is minor of minus 2 now? So minor of minus 2 is column is left. This column is not considered. This row is not considered. This is 1, 3, minus 1 and minus 1. And this 1 and 3. Then plus 4. Why plus 4? Because this is lying in the first row, third column. 1 plus 3, 4. Minus 1 raised power 4 is positive. This is plus 4 here. Now, minor of this 4 is leaving this column and this row not considered. This is 1, 1 and minus 1 and 2. Minus 1 and 2, 1, 1. Now let's solve it. 3 into minus 1 into 1 is minus 1. Minus sign in between we keep 3 is 6. This is 6 plus 2. This is minus 1 into 1 is minus 1. And minus 1 into 3 is minus 3, but it is plus 3 because in between we keep minus sign. This minus sign is there. Minus minus plus. Plus 4 into 2 into 1 is 2. Cross multiply. Minus 1 into 1 is minus 1, but minus sign in between we keep, so it is plus 1. Final value is minus 7. Minus 1 minus 6 is minus 7 into 3 is minus 21. This is plus 2 because minus 1 plus 3 is 2. 2 into 2 is plus 4. Then this is plus 4 into 3 because 1 is 3. 4 into 3 is 12. Okay, so this is the final value. So 4 plus 12, 16. 12 plus 4 is 16. 16 minus 25, 21. It is minus 5. Because 20 minus 6 is 4. And minus 21 plus 16 is minus 5. Minus 5 is the determinant value. Let me write here. This is minus 5 here. Okay. Now let us find out what is the value of D1 here. So the value of D1 is to be calculated for x, because x equal to D1 upon D. Here D1 is what? Let me write here the value of D1. What we write D1? Now this is D1, D2, D3. The equations values, they are kept in place of x, coefficient of x here. This is 5, 2, 1. A1, A2, A3 is replaced by the value of these equations. So 5, 2 and 1. They are kept here. This is minus 2, 1, 2. Coefficient of x, y and z are kept as it is. Minus 2. Only the first column is replaced by the value of the equations here, 5, 2, 1. Now let us solve it and divide by d is minus 5. The numerator, which is the determinant value, we have to solve, and that divided by minus 5. Minus 5 is value of d. That will give us the value of x. Variable x can be calculated. So let me solve the numerator, the determinant value. It is 5 into. Okay, let me write. It is as determinant value. It is 1, 3 with minus. Now in between we keep minus sign, but it is already the minus sign. It is plus 2. 2 into, this is 2, 3, 1 and minus 1. Then plus 4, and this is 2, 1, 1 and 2. Alright, so this will give us divide by 5, minus 5. In the numerator we have 5 into minus 1, 1 into minus 1 is minus 1, and minus 6. Then plus 2 into minus 2, this is minus 2, and minus 3. Minus 2, 2 into minus 1 is minus 2, and 1 into 3 is 3, but it is minus sign in between. Or minus sign. 2 into this plus 4 into the 4 minus 1. Okay, divided by minus 5. Finally, what will we get here? X equal to, because x is minus 7 into 5 minus 35. Minus 5 into 2 is minus 10. Alright. Then minus 2, minus 3, minus 5 into 2 is minus 10. Plus 3 into 4 is 12. But 4 minus 1 is 3. 3 into 4, 12. Divided by. So this is minus 5 here. Numerator is also negative sign. Why? But here it is plus 2, because minus 10 plus 12 is plus 2. Plus 2 subtracted from minus 35. Plus 2. Minus 35 plus 2 is minus 33. Plus 2 and minus 35, 33 upon minus 5. So it is 33 upon 5. This is the answer. Not coming as a real number or integer, but it is coming rational number. 33 upon 5 here. Okay, because this minus 10 plus 12 is plus 2 and minus 35 is minus 33. Minus 33 upon minus 5, that means 33 upon 5. Okay, so this is value of x. X is 33. So x equal to 33.5. Alright. Now let us find what is the value of d2. Now let us take d2 here for value of y. Because y we know y is equal to d2 upon d. Now d2 is, just replace the coefficient of y b1 b2 b3 by d1 d2 b3 by value of equations. This is 3, 1, minus 1. Okay, in place of minus 2, plus 1 and 2, we have to replace by 5, 2 and 1. And this 4, 3, minus 1, as it is, this d2 divided by minus 5. because D is minus 5. Now let us solve the numerator here. This is 3 into 2. Okay, 3, 1 minus 1, let me take. Okay, this is determinant value. Then minus 5, because this value is positive, but minus 5 which we keep. This is first row, second column. 1 plus 2 is 3. So minus 1 is over 3 is negative. It's negative minus 5 into this column and this row. This is 1, 3, minus 1 and minus 1. 1, 3, minus 1 and minus 1. Okay. Then plus 4 into this is 1, 2, minus 1, 1. So let us solve it, divide by minus 5. Okay, so in the numerator we have 3 into minus 2, minus 3, minus 2, 2 into minus 1 is minus 2, into 1 into 3 is 3, but minus 1 in between, so this minus 5 into minus 1, plus 3, plus 4 into 1, plus 2, minus 2 or minus sign kept in between, is plus sign, but by minus 5 here. Finally, what do we get? Let me write here. So in the numerator we get minus 5 into 3 is minus 15. Okay, then plus 2 was minus 1 plus 3 is plus 2, 2 into 5 is minus 5, minus 10, 2 into 5 minus 10, plus 4 into 3, 12, divided by minus 5. Again, what do we get? Different signs. I don't know why. Okay, let's check. This is minus 10 plus 12 is plus 2 and minus 15 is minus 13. Minus 13 upon minus 5 is 13 upon 5. All are rational numbers coming. Okay, value of y is also in rational terms. It's 13 upon 5. No problem. 13 upon 5. Value of y is 13 upon 5. No problem. Let us find out what is the value of z. For z we have to find out d3. So z is equal to d3 upon d. Again d3. What is d3? d3 is this coefficients of x by capital as it is or as they are. 1 minus 1 and this is minus 2, 1 and 2. But 4, 3 minus 1 will be replaced by the values of the equations. This is 5, 2 and 1. This is D3. Divided by D is minus 5. So minus 5. So it will give us, let me take 3 into 1 into 1 and 1 minus 4. That means that this is minus 2, so minus 1 plus 2. Let me multiply directly. This is 1 into 1, 1. Minus 1 into 2 is minus 2, but it is plus 2. So between plus 5 into this 2 into 1, 2. And minus 1 means plus 1. Total value divided by minus 5. What do we get? This is minus 3 into 3 minus 9. 3 into 2 plus 6. Here it is 3, 5 to 15. 3 plus 1, 3 into 5, 15 divided by minus 5. So what we get? We get here 6 minus 9 is minus 3. Minus 3 subtracted from 15 is 12. 12 upon minus 5. That means minus 12 upon 5. Why? Because minus 3 plus 15 is plus 12. I'm sorry. It is plus 12, but plus 12 upon minus 5. That means minus 12 upon 5. Z is minus 12 upon 5. All are coming rational numbers. No problem. They are coming rational numbers, not integers. Rational numbers are the answers of this equation. This is the process of solving with the help of grammar rule. What is grammar rule? Just replace the value of whatever the value of variable is calculated, that variable's coefficients are replaced by the value of the equations. Just like here 5, 2, 1, they are the value of the equations. The value of the equations will be replaced by the coefficients of the variables. Okay, the coefficient of variables are replaced by the value of the equations, and then we find out d1, d2, d3, and then divide by d. D is just determinant of the coefficients of the variables, which we have just done. This is question number 11 here. Now let me talk about question number 12, the last one. Now to understand the last question, 12th one, which is regarding orthosymmetric and schizometric type of determinants. What are the schizometric and orthosymmetric? Now, to understand this, let me define one term here. This is the 12th question. So first, what are the orthosymmetric and schizometric determinants? Okay, so orthosymmetric determinant. This is ortho, O-R-T-H-O, orthosymmetric determinant. And second is skew symmetric determinant. Skew symmetric determinant. These are the two types of determinants. Let me define them. Okay, just to understand this, we have to understand what is the conjugate element. First, let me define what is the conjugate. What are the conjugate elements? Because the definition of this is in terms of conjugate elements. What are the conjugate elements? Let me first define conjugate elements. Okay. Now let us talk about conjugate elements. Now the two elements in a determinant or in a matrix are the two elements in a matrix are known as conjugate elements. Are known as conjugate elements, which are